Hey there, grade six. A new video for you guys today. It is on solving equations, and the focus here is on preserving equality. And so your learning target for this lesson is that I can undo more than one operation to get back to where I started when starting with a number, and we'll undo one operation when starting with a variable, because we're in this new unit of algebra and patterns in algebra. And so there are some prior skills that you need to have. So one of them is that you knows that addition and subtraction undo each other, that you know that multiplication and division undo each other, and that's some of the stuff that I have here. You need to be able to substitute numbers for variables, and you need to know that the equal sign means that expressions on both sides of it equal each other. They are the same. Now, there's a little note in the bottom here that if you would like, there's a bit of practice in the workbook, sort of that's before we kind of get into new stuff. So you can pause it here and work on in the workbook on page 77 on numbers 1 through number 3 up to the end of letter I. After that, just stop your practice. You can pick up the video again. So on to some new stuff. So the first concept that we're going to look at is undoing operations done to variables. And so what it says here is that you undo operations done to variables the same way you undo operations done to numbers. And so if you were to have like 7 plus 8 to get back to 7, you would have to subtract 7 plus 8 minus 8, right? Same way here, if we have this algebraic expression of x minus 7, if I want to get back to x, all I have to do is add 7, and that's that concept that subtraction and addition undo each other. So x minus 7 plus 7, the 7s will cancel out and we'll go back to x. Okay. Likewise, if I have multiplication, division undoes multiplication. So n times 4 divided by 4 will get us back to n. Multiplication will undo division. So t divided by 3 times 3 will get us back to t. And then x plus 5, to undo that, it needs a minus 5. So x plus 5 minus 5 gets us back to x. Now, the next part that I wanted to remind you of is that the variable x, or any variables in algebraic expressions or in equations, they represent numbers. So you can treat them like numbers. And so here's some practice we can do with that. So if you multiply x by 4, what we generally say is that becomes, well, we know a couple of different ways. X times 4, that's the worst looking times sign ever. Or we could say 4x, which also means 4 times x. Over here it says subtract x from 2. And so you got to be careful. So that's 2 minus x, not x minus 2. So make sure with things like division and subtraction that you are paying close attention to what's being subtracted from what. Here, divide x by 8. And so that one just becomes x divided by 8. And this one says add 9 to x. So you start with your x and then you're adding 9. Okay, and so if you would like, you can pause it here and you can work on 3j to the end of number 5, also on page 77. And that will give you some practice undoing operations done to variables, and you can pick it back up again. So the next step that we want to try is working on ways to preserve equality. And so what we're going to try to do is looking at this equation, 3x equals 12. So we're going to try and figure out what's done to the variable. Well, we are multiplying this variable by 3, and that is going to give us 12. So the way we want to try and figure that out is how can we do what's called isolate x, or figure it out. What we can do to preserve equality is that we know that we can, if x is multiplied by 3, we can divide 12 by 3 to find out what x is. So that's going to end up being x equals 12 divided by 3, and that means x is going to equal 4. Now we are actually dividing both sides by 3 in this equation. Oh, sorry, I got all blurry. In this one, we have a variable and we're adding 3 to that variable, and that's going to give us 12. And so to figure out what that number is, we can subtract 3 from both sides to preserve equality. I like to line my equal signs up. So that becomes x plus 3 minus 3 equals 12 minus 3. And so we know that that's opposite's going to cancel out. So that leaves us with x. And then 12 minus 3 is 9. I almost wrote 8. It's 9. So then we can check it out. 9 plus 3 equals 12. Here we have some number divided by 3 equals 5. And we know that multiplication undoes division. But we have to do that to both sides, because if it's called preserving equality, then that means that this stuff happens on both sides, because you want to preserve the equality of the equation. So again, back here as well, right? That stuff gets done to both sides. So that divide by 3 times 3 just cancels out, leaves us with x on the left side of the equation, and then 5 times 3 is 15. So we can go back and say, well, 15 divided by 3 equals 5. And here x minus 3 equals 5. To get rid of a minus 3, it's the opposite operation is plus 3. And then I'm going to add that to both sides because we preserve equality. So then that cancels out, leaves us with x over on this side, and then 5 plus 3 is just 8. And so you can double check. You can substitute 8 for x and say 8 minus 3 does equal 5. Okay, so then writing that steps out again, we have to divide both sides by 9 to get to even that out. So that becomes 9x divided by 9 is 63 divided by 9. So those 9s cancel out. And then so that leaves us with x equaling 7. And you can double check. 9 times x is 63. 9 times 7 is 63. Okay, this equation 33 equals 3x. Notice that it's set up sort of different. The left side and right side look different, but the steps remain the same. We have to divide both sides by 3. So you have to have 3x divided by 3 on this side, which means that you're dividing 33 by 3 here, which means that 11 is going to equal x. And so you can double check that. 3 times 11 equals 33. And then this one again, we have to undo the divide by 7 with a times 7, and then do that on both sides, which means that x equals 21. And you can double check it. 21 divided by 7 does equal 3. And so at that point, you can do number 6 on page 78 in your workbook. And that gets us on to the next. Now that we know how to preserve equality on both sides, this one gets a little bit more interesting. This concept of treating variables as numbers. So we know that we can treat a variable like a number because it represents a number. So that means that we can subtract the variable, add the variable, multiply or divide the variable, right? So what would you write to subtract x from 3? We would write 3 minus x. Notice that we're subtracting a variable. What would we do to get back to 3? Well, we'd have to undo that minus x, so that would become 3 minus x plus x. We're treating x like a variable. We're treating the variables like numbers. And so when we see something like this, 5 minus x, and we want to get back to 5, we have to add x. If we have this one, 4 equals 4 minus t, and we want to undo that t, that minus t, we have to add a t. Now notice that the variable is not an x. It's still a letter though. So any letter can be a variable. Here we have a z. But we want to get back to the 9. So we have to add a z. And here we want to get rid of this minus x. And so we write down the plus x. And so there are some questions in the workbook that sort of focus on that concept. And so I'll give you a little example. Let's see, try to make one that's not super difficult. Let's see, we have something like 3 equals 15 minus x. And so we want to get rid of this x on this side. And so that means to get rid of it, we have to add x. So, but to preserve equality, we have to do it on both sides. Okay, so I know this looks kind of weird, but so that cancels out. So what we're left with is this 3 plus x equals 15. Now we want to get rid of the 3 on this side, which means we also want to get rid of it on this side. And so that becomes 3 plus x minus 3 is 15 minus 3. So we do it on both sides. So that plus 3 minus 3 reduces down to just x. And then 15 minus 3 is 12. And so you can double check that. You can plunk 12 back in up here and say 15 minus 12 actually does equal 3. Now the last little concept that I wanted to show is just preserving equality in two-step equations. And then, so now this two-step equation here, we got to do a couple of things. First, we want to get rid of the minus 1 off both sides of the equation. So when you're doing these things, you want to get rid of the minus or plus number here if you can, and then worry about the division after that. So then the way to get rid of a minus 1 is with a plus 1. And then you have to do that on both sides. So that's 11 plus 1. So that minus 1's cancel out. So we're left with 3x equals 12. And so now we've gotten rid of the minus 1 off both sides of the equation. Then what we have to do is go into our sort of next phase, where to get rid of the 3, we have to divide it out because it's 3 times. So that's going to be 3x divided by 3 to get rid of it. And then again on both sides. So that means that 3's cancel out on here. So we're just left with x. And then 12 divided by 3 equals 4. And so we're figuring out that x equals 4. And so you can plunk that back in. 3 times 4 is 12 minus 1 equals 11. So that is verified. That does work out. The last thing is that sometimes we have equations that have more than one variable. And so I have an equation here that x plus 3 plus y equals 9. This one at this point is unsolvable. X and y can be too many different numbers. If, for example, you're given a number, and let's say here x is equal to 4, then we can do that substitution. So we would have 4 plus 3 plus y equals 9. So then that becomes 7 plus y equals 9. Then we want to get rid of that 7 off both sides. So that becomes 7 plus y minus 7 equals 9. Sorry, not plus, minus 7. And then we're left with y on this side and then 2 over here. So if we're given the value of one of the variables, then we can solve it. Otherwise, if we're not given, then we can't use that. And so that's what I wanted to show you about preserving equality. And so you can finish up any other practice you have in the workbook from that lesson. And I hope you guys have a great day.